Okay, this video that I'm going to do right now is on quadratic review number 2, and I'm going to do number 3, which is a max area problem. And I wanted to make sure that everybody was clear that you can do this more than one way and be okay. So this one right here, I'm going to draw the picture here. It says a rectangular field. Now that's important that it says rectangular because there's certain properties with a rectangle that we know. We know opposite sides are parallel. We know opposite sides are congruent. So that helps us. And it's going to be fenced in. Sorry, it went away. It's going to be fenced in on all four sides. There'll also be a line of fence across the field parallel to the shorter side. If 900 meters of fence are available, what dimensions of the field will produce the max area? So let's kind of draw the picture first so we see what we're talking about. So I'm going to draw this picture of a nice big rectangle, and it's not very pretty here. Hang on a second. I think my bracelet keeps hitting this, so I'm going to try this after I do this video. I'm going to take my bracelet off. All right, so now I've got ready a rectangular field, nice big rectangular field, and I'm going to fence it all the way around. So I'm like, okay, that's cool. So here's my fencing all the way around. That's what they said at first. Then it said we're going to do another line of fencing parallel to the shorter side. So this is my shorter side. So I'm like, okay, we're going to do another line of fencing parallel. So it's right down in the middle. Not so pretty, but there we are. Okay. So here's my picture. All right. So it says if 900 meters of fence are available, what dimensions of the field will produce a max area? So this is how we're going to set this up. First of all, we got our constraint, and our constraint is going to be our amount of fencing. Okay, our constraint is the fencing, right? And the fencing is all I have is 900 meters. All right, so like I'm just trying to help you set this up so you can kind of think it through. The objective that we have, or what we want, I guess, the objective is max area. I want the biggest area I can have for my fences. Okay, that's my max area. Okay, and I know area is length times width of a rectangle. So I'm kind of do this. And when I'm doing constraint of the fencing, I'm actually talking about perimeter. Okay, so I'm going to kind of set this up for you down here. So I'm going to do constraint again. So we can do the algebra. We have a whole page to use. And I've got my objective, which is the max area. Okay, so when I do this, I'm going to label my pictures. Now this is where you have control how you're going to label this. So I'm going to pick a different color here. And I actually called this side Y because they're all the same. I know because opposite sides are parallel congruent. And that's kind of like the y-axis. And then I have a choice, kind of. I could call this whole side x and this whole side x, or I can call each piece x. It works either way. When I talked about this to the kids in class, they wanted me to call each piece x, so I'm happy to do that. And I know they're all congruent because it's parallel, and it's a rectangle, and I know I know all the properties. And I'm using Christmas colors. This is awesome. All right, so the first thing is I'm going to do the fencing, and I know it's perimeter, but not only is it going to be all the way around, I've got to add that middle in there. So I have 4 x's, and I have 3 y's have to equal the 900 meters of fencing. That's my constraint, okay? And that's according to my picture. My objective is I want max area, so I know area is length times width. If you can see the length, it's 2 x's times y. So it's almost like you're making your own equation based on your picture. Okay? So now let's get started on the algebra. So I'm going to solve for y. You could solve for x, but it doesn't matter. So I got 900 minus 4x. And then I'm going to divide by 3. And when I divide everything by 3. So 900 divided by 3 is 300. And that's going to be a minus 4/3 x. Now I'm going to take this that I just found, this right here. I'm going to take it and plug it into this spot here so that this objective will put in the 900 meters of fencing that I have to have. All right. So let's go back to this pretty color. So I got A equals 2x times 300 minus 4/3 x. Now I'm going to distribute the 2x. Okay. So the area is going to be 600x minus, now if you multiply that fraction by 2, it's like 2 over 1. That's going to be minus 8 over 3x squared. Okay, now I see that this is a parabola, or it's a quadratic formula, a quadratic function, if you will, and it opens downwards because my a is negative. So I'm going to have a max, and so I want to find the max area. So I'm now going to use my famous axis of symmetry, x equals negative b over 2a. Remember, this is my a, this is my b. It's like backwards, okay? And so when I put that in here, I get, right, negative 600 all over, that's a 6, guys, over 2 times negative 8/3. So that's a 6. Make that nice and clear. And when I put that in my calculator, I get x to come out to be 112.5, and what we're talking about is meters. So that's what my x is going to be according to my picture. So I can come up here, say this is 112.5 meters. Get the idea? 112.5 meters. They all are. Okay, so I'm going to come through and do my picture. 112.5 meters, 112.5 meters. Now, I did have someone go, Mrs. Pond, when I do find the other sides, I just add all those up. There's 4 of them. Subtract it from 900 and divide by 3. I said, well, that's kind of what this equation is here that I have circled in yellow. So go ahead and plug it right in here. So I said, oh, wait, what's my y going to be if my x is 112.5? So it's going to be 300 minus 4/3. You kind of already set it up. So you can do that, and that means you understand it, and that's perfectly fine. Or you can actually use the equation you came up with. And when I did that, I get my y's to come out to be 150 meters. Right? So there's this. So I'm going to come up here and plug in the 150 here. This is 150 meters here, 150 meters here, 150 meters here. So now I know the dimensions of my field for the max area. But remember, they asked up here, what is the max area? So they asked me for the dimensions. I did. Okay. So my dimensions of my field, so let's do the dimensions. The dimensions of the field, okay, are going to be, ready, the whole field, okay, is, I've got this added together is 250 meters by 150 meters. So I actually added these x's together. So my whole field is 250 meters by 150 meters. And then it says the max area is what I have to do next. And the max area is, I'm going to say, oh, area is 250 times 150. And they're both in meters. So my area comes out to be, ready, 33750, 33,750 square meters, or meters squared. Okay, so there is a max area problem that you can see and do. And now remember, you could do this another way. I just wanted to show you all the ways you could do this. That's the end of this video.